All right, let's get started here. Welcome everyone to Historic Range of Variability, Uses and Various Approaches. Today's webinar will be joined by Nathan Poage from the Forest Service. A couple of ground rules before we start. Please mute your microphone this entire webinar unless I tell you otherwise. Please also keep your video disabled. The chat box will be restricted to hosts, so please ask all your questions directly to me and I'll make sure Nathan gets them. Anyone who disregards any of these above rules will be subject to dismissal. So let's just be respectful and hear from Nathan. So I'm going to pass the screen over to Nathan. He'll share his screen. Welcome, Nathan Poage. Thanks for hosting today.
Hey, everyone. And let's see. Okay. If you cannot see this, definitely let Sally know. And I'll probably try to keep this in this mode because it's a lot easier for me to see what slides are coming up. But if the resolution is not good enough for anyone, let me know and I'll go to full screen mode. So this is really fun. This is going to be probably the third or maybe fourth version of this talk that I've given. As Sally said, my name is Nathan Poage. I'm currently with the Northeast Oregon Area Ecology Program. That's the part of the Region 6 Pacific Northwest Ecology Program on the National Forest System side. And this is something that's been growing, I think, for the last couple years. This is a concept that I've been starting to dive in. And then most recently, in this past year, I have been thinking about doing a talk, or I began thinking about doing a talk earlier this year or late last year, because one of, or a couple of the collaboratives that I work with over in the Blue Mountains in Northeast Oregon, it was pretty clear with some of the things that were going on that there was some confusion about range of variability and natural range of variability and historic range of variability and what these were. And so I thought, you know, this might be a good opportunity to maybe help clarify that. And that was not just for the participants, it was also a little bit for me because of where this concept has plugged into a lot of the things that we do over here and the importance for some of the issues like the Eastside Screens revisiting. So I jumped on this opportunity and it was kind of on the heels of a talk that was given by, and I want to acknowledge Jessica Hudek, some of you may know her, who is part of the ecology program, who gave a talk on range of variability at the Region 6 Ecology annual meeting last October. And so with permission, I borrowed a couple of the slides from her, primarily terminology and a couple of the things that help set the stage. And I've kind of run with it. This will probably have, just because of where I am in the world, a stronger focus on the Blue Mountains and how things are sort of done over here, or at least have been for the last decade and a half or so since the Eastside Screens came in. Anyhow, we've got a couple different variations on this. If you hear NRV or historic, HRV, current, pick your letter, put it in front of range of variability. Some people will also talk about range of variation. Some of these terms we might use somewhat synonymously, other ones are distinct. But use a couple of Jessica's slides. Here we go. These are from her. There are going to be a number of different definitions. These are ones that she had distilled down. But starting with the natural range of variability, it could be defined as ecological conditions and the spatial and temporal variation, it's the variation that's important, in these conditions that are relatively unaffected by people within a period of time and geographical area appropriate to an expressed goal. So I added the red highlighting because, at least in this part of the world, I think it's fairly safe to say that there are not many portions of the landscape that have not been affected by people. We have had human beings in this landscape for thousands of years. I think it's safe to assume that they have had an impact, unintentionally perhaps, but also I imagine in many places and in certain ecosystems, a very intentional impact. So take this with kind of a grain of salt. Another term, HRV, we'll use this simply NRV, when the reference period is prior to what defines current conditions, and that is often assumed to be, or we use, maybe not assume, but we use the sort of pre-European settlement period. Again, I want to stress that that does not mean that the landscapes were not impacted by people, simply that we're picking a reference period or reference condition that predates that period of European settlement. And really, I think in the Blue Mountains and in other areas that we consider sort of to have more frequent fires, really what we're looking at, I think, is when fire behaved, broadly speaking, in a different way than it does at present. So again, take these terms with a grain of salt. Just recognize that when we've got a reference period, that historic range of variability has often been used or defined in terms of pre-European settlement. Future range of variability, FRV, this is going to be an interesting one. We may or may not have historic analogs for some of these, and this is perhaps especially relevant when we think about the effect of anthropogenic stressors, things that might be related to climate change. So let's move ahead. One of the things that's really, really important when we're looking at any kind of range of variability is that if you're making a comparison to conditions at present, you need some sort of reference condition. So HRV, that historic range of variability or historic conditions, is something that needs to be established. I'm throwing up this. This is only shown as an example. I'm only using this for purposes of illustration, but let's just say hypothetically, this is a view that's been reconstructed of the north half of the Umatilla in these broad forest types using things like government land office survey records. Again, I really want to stress this. Please do not take this as a reconstruction and that this is what has been being used, all right? I just want to throw this point up that when we are dealing with range of variability and making a comparison to contemporary conditions, that we need to establish some reference conditions. So again, from the point of view of the historic range of variability, we need reference conditions, and we're, in many cases in this part of the world, using that period post-European or pre-European settlement as our set of reference conditions. Why do we use that? Again, this fire change, it isn't that there's anything magical about, say, the 1850s, 1830s. It's just that that's where, with written records, surveys may be done, 1850s, 1870s, late 1800s in there, we have actually written records. We can augment that with oral histories, but if we're trying to go for what we have sort of documented, it's going to be that mid to late 1800s, which can form the basis for it. So what do we do with that, right? This is kind of a static snapshot, but we know, and this is now getting at this concept of range of variation. This is how Dave Powell would put it. Range of variability, Kenny Morgan down here, which this figure is modified from, had what I would call maybe a classic or at least well-cited paper that kind of laid out a framework for considering natural range of variability or historic range of variability. In this case, we're looking at, this could be any time period, but really what we're looking at is if we look at a particular area of interest, like that map that I showed previously, we might say break that map up into watersheds, and we might look across those watersheds, and on a watershed by watershed basis, we might look at the percentage of the landscape that, say, is in a particular forest type or vegetation type, let's say grand fir, and we might across those, that entire area of interest, say a forest or maybe a portion of a state or an ecoregion, we might, on a watershed by watershed basis, we might sum up and say, wow, you know, it looks like in the places that we would consider to be, say, grand fir forest types, it looks like we had somewhere between 25 and maybe 75% of the landscape in that particular forest type might have been dominated by that. Alternatively, we might say, these are what we reconstructed our past to be. Here's what we think about fire probabilities. Here's what we think they might do to, say, forest structures. And so we might, over time, kind of say, you know, we think we might model, this might be expert opinion, this might be based on literature reviews, this might be based on something called state and transition models that I'll come to at the end of this talk. But we might construct, you know, sort of based on what we think we had at a particular starting point in time. And our rule sets, like this is the probability of low intensity fire, and this is what it might mean for that particular forest structure type. We might follow that or model it out, or maybe we have journals from people, maybe we have oral histories. However we end up getting at it, we could construct sort of, you know, this is pretty much what we think during our reference period, that the percentage of the landscape that was occupied by this particular thing we're interested in, how it sort of wandered and varied. So we have a couple different ways of doing it. The important point is that for our reference conditions, we can establish this range, a lower limit and an upper limit. Where this begins to play out is that the Forest Service, and I suspect other entities, use NRV, and I would begin with, I'm going to use NRV and HRV somewhat simultaneously here, or so if you hear one, think about the other. But essentially, the way a lot of management goals have been defined is to use a combination of natural range of variability, contemporary conditions, and then to look at how those vary, to do a departure analysis. The goal often of our management is to maintain conditions within this natural range of variability, or within this reference range of variability, and where we've got a departure from that, to maybe restore the current conditions to reflect that natural range of variability. This has direct implications to the Eastside Screens and the so-called 21-inch rule. I'm going to go back to the previous slide. Very briefly, this is not a talk about the Eastside Screens. I'm really not qualified to say a whole lot about that. But basically, for the purposes of the Eastside Screens, and one of the hot topics now is that about 25 years ago, there was more or less, with some exceptions, without, say, a forest plan, there was more or less a prohibition on removing trees larger than 21 inches unless that particular class, or in a case where maybe there were a certain number of them, whatever HRV was being used as, if there was an overrepresentation of those trees or those forest types, and I'm paraphrasing, so don't quote me on the exact language here, but if there were an overrepresentation, then under certain circumstances, without, say, a forest plan, some of those trees could, in fact, be removed. If you were below that, it became much more difficult to do that, because really where the goal of management was to keep us within this reference range or historic range or natural range of variability. So what's interesting is, and you know, as I started to dive into this, the question comes up of, well, how do you decide that? And what approach do you use? And so I went digging, and I just wanted to throw this up in the wake of the Eastside Screens. This is a direction letter from 2011. And as far as I've been able to determine, and I've had a confirmation of this from one of the district rangers and a couple of the other people that have been around for a while, this still represents for the Wallowa-Whitman how HRV or NRV was to be defined, and the process through which one might go, not necessarily the process, excuse me, but what was to be used to define that. And so I simply throw this up to say that there were decisions that were made across the Blue Mountain forests, the ones I work with, the Malheur, the Wallowa-Whitman where I'm based, and the Umatilla, all three of those forests use the variation on this. And the key down here is that these range of variation recommendations for dry, moist, and cold forest were put forth by Dave Powell. I think originally maybe 1998 and then modified and updated in 2010. But basically this was a letter of direction saying the best available, this is going to be used and considered best available science. And at least from 2011 forward, that all future forest vegetation planning work should utilize the range of variation tables in this document. So, you know, it's nice to see that there is direction on that. Again, other places may have tackled this differently. I really don't know. But in the blues, broadly speaking, this is how it was done. And I want to just sort of show you, take a little bit closer look at one of the tables that was referenced in there. Take this again as sort of an overview of a general approach. Not that this is carved in stone or the best way to do it, but this was reflecting the guidance as of 2011. And so, for instance, for some broad potential vegetation groups, maybe cold upland forest and moist upland forest and dry upland forest, it was considered that these broad structural stages, so seral stages, stand initiation, so following a significant enough of a disturbance that we get a cohort of trees going. Over time, those might grow up, move into what might be considered a stem exclusion phase, where we begin to see these self-thin as that breaks up. And this is a very simple sort of 4-box model. Understory reinitiation, a term that I first came across in this by Oliver and Larson. And then finally, moving into an old forest, which in this part of the world, it makes sense to split things into maybe an old forest single story, what maybe this would look like. Or if we had, say, ponderosa pine overstory with maybe grand fir coming in some places, we might move into something like an old forest multi-story. And based on that, kind of look here, these based on maybe historic reconstructions, some cases perhaps expert opinion, that we could come up with for each of these broad groupings, we might come up with that we'd expect that our sort of range of variability, our reference range of variability might be 20 to 45% of the landscape we might expect in these cold upland forests to fall into this broad category of stand initiation. At the other end of the spectrum on these cold upland forests, we might expect to see 10 to 25% fall into this old forest multi-story. In contrast, let's take a dry upland forest. We might see a slightly smaller, narrower range down in this stand initiation stage, and very little in this old forest multi-story, but a whole lot more in this old forest single story, which kind of makes sense if you think about it. Something like this might be a little more indicative of where perhaps we'd have a lower intensity, more frequent fire coming through and perhaps killing off some things like grand fir that might be a little more susceptible when they're small, at least, to that fire. So this is sort of the broad approach. And again, just to kind of take us back to where we were, it would be looking at these ranges. And if this is where we expect, you know, a stand or a vegetation patch, whatever your unit is, I use the term stand somewhat loosely here. But if this were, again, for, say, this old forest single story, that this is sort of where across an area of interest, we might expect it to be wandering. And if we're in there, then we'd say, yeah, we are within those reference conditions. Okay, moving on. So how has that been done in this part of the world? When we're doing, and this, again, I can speak for the Malheur, Umatilla, and Wallowa-Whitman as a broad general approach. How has this actually been done? Those previous slides gave some guidelines on sort of what those ranges were for those particular, breakdowns of the landscape in terms of in this case, vegetative structures. How this plays out or has played out in many cases in practical terms, say at a, some project planning where, I don't know, a 10 to 80 or 90,000 acre area might be being looked at, kind of like up in here. This, for those of you that know the Wallowas, this is a project that is emerging called the Morgan Nesbitt Project. And to get you oriented, we're kind of on the south end of the arc of the Wallowas. And Wallowa Lake, that really neat sort of glacial moraine dammed lake coming out, is just off the screen over here to the west. This area is about 80 or maybe 90,000 acres. The outline is in blue. These white blobs are sort of correspond to watersheds. They're not perfectly, you can see the square lines here, but they roughly correspond to a certain scale of watershed. But the way that for similar types of projects, and I think this will be done here as well, would be to take inventory data, which we might refer to as stand exams for those of you that are not familiar with it. These are have been collected at various points in time and are stored in this Fsveg, standing for Field Sampled Vegetation, corporate database. They are by no means all from the same time. They might be 20 years old. In this part of the world, an exam that's 20 years old, if it hasn't been, say, compromised through a fire, and I don't mean compromised, I mean disturbed so that if we grow it in the growth model forward in time, that it's going to suddenly look very, very different. But, pretty much what we do in a sort of a typical project like this is to take a stand exam, and let's say this little red dot down here, this is maybe a cartoon view of what it might look like in 2020. Well, let's say that exam were put in 2010, and I have other ones in maybe 2012 and some from 2019, but not all of the vegetation polygons out there actually have a stand exam, is that we use some pretty interesting sets of tools. These are GIS add-ons, one of which is this Fsveg data analyzer. And that allows us to do a couple different things. One is we can use that to essentially project or impute stand exams where we do have them to vegetation polygons where we don't actually have a stand exam. And we go through this imputation process where, and let's just say for argument's sake, maybe only 10% of the stands that are actually in this area of interest. This could be an entire forest. It could be a tiny little watershed. In this case, it's for this full project area. But let's say, again, maybe only 10% of the stands actually have it. We use a combination of satellite imagery, so reflectance data, Landsat, which goes back to, I think, about 1984. And we try to match, based on those spectral characteristics, in other words, what it, quote unquote, looks like to the satellite, and topographic characteristics, so slope, elevation, and aspect, combine those and kind of come up with a set that match where we do have a stand exam. So in other words, and this is just for illustration purposes, let's say every one of these little red polygons out here, all of these up here, they don't actually have a stand exam, but we do have a stand exam here. And the way we've done this classification, we think that those red ones are most similar in terms of topography and the spectral characteristics, that we're going to impute or essentially copy this stand exam from here over to this one and to this one and to this one. So this is sort of a copying exercise. But this is how, for many projects, particularly these larger scale ones, we go about generating a wall-to-wall estimate of what we've got in terms of vegetation. One of the things I will say, for those of you that have perhaps gone out to inspect these things, you might ask to get the stand exam for a particular stand. Well, if that's been an imputed stand, you may find that what was here is not actually out here, but in aggregate, they're going to work out pretty well. So anyway, we go through this nearest neighbor imputation to project our stand exams, and then, and we're all headed here to how are we actually doing this departure analysis? And then we take the forest vegetation simulator, an unfortunate, another combination of F, V's, and S's as opposed to F, S's, and V's, which is essentially a publicly available growth model. Anybody online here can download a copy, get your local version. We use the Blue Mountains variant of FVS. It allows us to take the stand exams. It, meaning the data analyzer, allows us to take the stand exams, the imputed stand exam data, and run them through the forest vegetation simulator in what I'll call batch mode. Maybe I'm dating myself in the computing world, but essentially to take those stand exams that maybe are 15 years old, 10 years old, 20 years old, and grow them up to the present to give us an estimate of our current structures out there, and then make a comparison of what we currently have to our reference conditions and see where are we departed from our reference conditions. That's where we get this NRV departure analysis. I will say one thing that also goes on is that we cannot just grow exams up to the present, but then this is really how we play out different alternatives. And for instance, the no action alternative for this particular stand might be to grow it out for 50 years with no additional disturbances. And at least for the overstory trees, I'm not showing any understory or ingrowth that might come in. We fully expect that it would be there, but at least for the overstory trees that we believed were there in this modeled world at present, 50 years down the road, this is what we think or what we get based on our modeled projections. And so we can do that also. We can play out different scenarios. If I were, for instance, to do nothing, this is what I might have in the entire project. I might be able to say 50 years out, this is how this entire project area falls out in terms of the percentages of this particular forest structure. And that would allow us to say, are we or are we not within the range? One of the things about the vegetation simulator, though, it's a really, really neat tool. You need to know, like any model, you need to know its limitations. And I won't really call this a limitation, but it's really important to recognize that this model has, in and of itself, no random elements built into it. So what that means is if Sally, for instance, has this project opened in front of her and is running the forest vegetation simulator for the stands in it, and she runs it for 50 years doing nothing to the input data other than let it grow, and I do the same thing with the same starting conditions, she and I are going to end up with exactly the same landscape 50 years out. So there are no random or stochastic elements to the model. That doesn't, unless you start changing things around, that in and of itself really kind of gives you a point estimate in time based on a couple things that you've changed. That's great for comparing alternatives, but it doesn't really let you get at that range of variability. Another tool or set of tools that do maybe are a little bit stronger at doing that kind of thing are state and transition models. So I'm going to go ahead and move over to talk about a different kind of model, state and transition models. I think that most of us, if we were pressed for any kind of system, to sort of describe how to conceptualize, to reduce a very complicated system to something that's a little more, simplified for the purposes of kind of getting a handle on it or describing it or maybe gaming out. Most of us mentally build these state and transition models, even if we don't think about it. So let's just say we were standing out in a particular patch of forest, and let's say we were talking about how do we think this forest is going to develop over time, right? We would be building, and I've brought in an envelope just to make the point that you could do this on the back of an envelope. And actually, I'm getting really curious about whether this might be a great exercise for collaborative groups to do, because again, I think we do this when we stand out, in some portion of the landscape and speculate on where did it come from, where's it going, what might influence it. But if we were building, let's say we're standing out in the woods, right? We're building a very simplified forest ecosystem model, very simple. Maybe that suffices. And we might say, well, yeah, we think it probably went through some sort of early seral or developmental stage. We think probably after a while, time goes on. If nothing deflects that trajectory, we might call it mid-seral, right? Sort of middle-aged, if you will. But again, this is a real simplification. Then at some point, as we kind of go on in time, we might move it into some sort of late seral. Maybe some people would call it old growth. Some people might call it old forest. But from a conceptual, just really simple starting point, this sort of 3-box state and transition model is something that we can build. Again, if we don't have, say, a disturbance, and we're really just dealing with these deterministic or maybe time-based or age-based transitions, we could have this 3-box model that just kind of goes along like this, getting, the older trees in the stand are getting older. Maybe some things are cycling around, but this is how we can kind of build a model. But we know that's really not the way the world works. And sooner or later, somebody's going to say, well, wait a minute, what happens if we have, say, a disturbance? And just keep it super simple here, maybe 1 out of 100 years, but it could be next year, it could be 2 years in a row. We have a stand replacing fire that takes, and with a certain percentage of the stands or patches that are out there that are in this late seral category, we might say there's a 1% chance in any given year that some or all of the late seral stands through fire or some other disturbance, it might be cutting, take your pick, you can build your model however you want, might send it back to this early seral state. So, we might say, hey, we need to do something with mid-seral and send it back that way. Maybe something might speed up the transition. I'm not quite sure how you do that, but speed up the transition from this mid-seral category to a late seral. Again, your model really needs to reflect what questions you're trying to answer. So here we are. This is, let's say we were curious about, now doing our range of variability for this landscape, for these structural stages. We could sit here with a clipboard and we could say, just start arbitrarily at time 0. We could say the entire landscape is in this condition, and we could say that, as time goes on, it moves over here, and we could kind of do this until we are out, we've got some late seral, and then at that point we start rolling the dice every year and see what happens in terms of, say, a stand replacing fire. Well, that gets kind of difficult in terms of the record keeping. And so we can go to a software-based approach and take that same back of the envelope model and drop it into some software package that will allow you to build models. Again, you're seeing the same sort of boxes, and essentially game this out over long periods of time. So you're rolling the dice a whole lot, and to do sort of multiple runs. So you could do an iteration where you start a landscape and you roll the dice for, you go out 200 years. Every time step in there, if you say you're working in an annual time step, you kind of progress that along, and then you say, okay, that was sort of, one gaming or one iteration. Let's do it again. And over time, you could build up the outputs, over time, and begin to build a window of this is what we expect in terms of our range of variability that's coming from this very simple model that we built. So in this software world, and this particular one is coming from something called SynchroSim, which is really the software, and then the module that allows you to do that is an add-in into this, is STSim. I may use the terms back and forth. If you hear me saying SynchroSim or STSim, think this sort of generation model. The precursor to this system was PATH as kind of the controlling software, and VDDT. Some of you may know that as an abbreviation. Essentially, this SynchroSim/STSim world represents the next generation of those earlier PATH and VDDT models. But in this particular case, we might define a state by its cover type. And for the purposes of this simple model, we'll just call it a forest or forest ecosystem. A structural stage, which I've just chosen to call early seral. And then I'm arbitrarily setting this age-based transitions that as long as it's between 0 and 24 years of age, it's going to be in this box. The minute this particular patch turns 25, it's going to move into a new state. If we're just having these deterministic time or age-based transitions and go on, from there it might sit in this mid-seral as I've chosen to define it, just for purposes of illustration, and do this any way I want, as long as it's reflective of the conditions that I actually am trying to model. And based on the rule set that I created for this particular model, between 25 and 99 years of age, this particular patch of vegetation is going to be in this mid-seral. And then when it tips over to 100, we move into what I've defined as this late seral. However, in the background, because maybe our landscape, for instance, when we start out is 12% of that landscape is in this early seral form, and let's just say for argument's sake, 38% of it, a little over a third is in this mid-seral, and in my particular landscape that I'm looking at, 50% is in this late seral. So for that initial 50% of the late landscape that's in late seral, starting out at least, I'm going to say that there's a 1% chance per year. So for every time we roll the dice, there's a 1% chance that we're going to have a stand replacing fire that is going to send some or all, however we chose to define it, of these late seral stands back to this early seral condition, which is going to increase the amount of early seral. Meanwhile, some of that is growing out into this mid seral, and so on. There's this random or stochastic element built into this model. This is how these state and transition models differ from, say, that forest vegetation simulator approach. And it's a way that I think really can be used and has been used in some of the planning efforts to complement that forest vegetation simulator based approach. Similarly, you can use the forest vegetation simulator, assuming that you're happy with how the model's performing, to validate, say, your transition probabilities. In other words, in a particular forest type, does it really make sense? Should we perhaps allow things to remain in this early sterile state longer, or should we move them more quickly into this mid-seral? So a couple of illustrations. I'm going to show two scenarios, scenario A and B. They're basically built off of this very simple model that I've got. My little landscape is got 100 1-acre cells. I'm going to run this aspatially, so I'm not going to influence my transitions based on who's next, what stand or patch of vegetation is next to another patch of vegetation, although this model does allow you to do it. I'm going to have this little, again, just little aspatial. 12% of that landscape is going to be in this early seral condition, 38% is going to be in this mid-seral condition, and 50% is going to be in this late seral condition. In terms of the simulation iterations or per scenario, I'm going to have 5 iterations. So for per scenario, scenario A or scenario B, I'm going to essentially run this 5 times, and each time I run it, I'm going to run it for 200 years. The only difference between scenario A and scenario B is that in scenario A, I've arbitrarily chosen to set the chance of a stand replacing fire at 1% per year. In scenario B, this is kind of getting at the question, you might think of this in an extremely simplistic, for illustration purposes only way. What happens if we've got a change in climate that increases 4-fold the probability of a stand replacing fire in any given year? What's that going to do to, for instance, the amount of late seral forest? So I'm setting up again a scenario A, which I'll show you first. That'll be the next slide. And then a scenario B. We can see how these, under those 2 different scenarios, how the amount of early seral, mid-seral, late seral varies over time, and sort of what the highs and lows appear to be, which can help get us at that range of variability. And then in the very final, or next to final slide, I'm going to compare, so we can really compare those scenarios, just looking at how under those different fire regimes, how the amount of late seral might vary. So here we go with scenario A. Can everybody see this, or should I go to full screen? I'm going to go to full screen. This is a little bit hard to see, I think. Okay, so basically what I did is for this scenario A, it's kind of blocked up here, at least on my screen, it's kind of blocked at the top. We're looking at a 1% chance of a stand replacing fire in any given year. Again, that only impacts late seral, but it takes the late seral patches that do experience that and sends them back to early seral. We start with about 12% on average of the landscape is going to be in early seral. About 38% is going to be in this mid seral, this mid box right here. And then about 50% starting is going to be in this late seral. I run this out 5 times. I'm choosing to show as the blue line what my iteration number 5 was, but this envelope behind it in the background is showing the highs and lows for every year for all 5 of the iterations that were run for this scenario A. And so you can kind of see that over time, we might say that given the model that we built with the rules that we embedded, which include a 1% chance per year of a stand replacing fire occurring to any one given patch of that late seral, we might expect that our range of variability for that early seral is going to be somewhere between maybe, I don't know, 3%, 2%, and maybe up around 20 or so percent. And that's our range of variability. If we kind of look out over time, that's maybe what we'd expect. And so this might be a way of saying, this is what we're going to use or help to use to define our range of variability. This is also a way, if we are looking at alternatives, maybe what we've modeled out here is one of our alternatives in our planning effort, and we could say, oh yeah, okay, this stays within the range of variability that we set based on our reference conditions. Similarly, if you look at the mid-seral in here, I think we arbitrarily set it to be on average about 38% of the landscape starts out in this mid-seral, but you can see that over time we would expect that the range of variability for this mid-seral class along the landscape is going to fall somewhere between maybe 50% at the high end and maybe, I don't know, about 25% at the low end. And our late seral, which started at about 50%, is going to fluctuate, or we would expect it based on this modeling effort, to be somewhere between about 40 and 70% of the landscape. Okay, so that's scenario A with an assumed fire return interval of 1%. What happens if we quadruple it? Again, in our modeled world, don't take this as gospel. This is really just a way of comparing our different assumptions. But we see if we change that probability from 1% to 4%, and then otherwise run out 5 iterations, each for 200 years, generate the same sort of window of minimums and maximum values over time, and then say overlay it on top one of those particular iterations, that dark blue line, we can see, kind of not surprisingly, that if we quadruple the amount of fire that we have in the landscape, let's come down to the late seral. Number one, we are rapidly losing in our modeled world late seral until we stabilize or wander around in a lower range. Whereas that late seral, the ones that do in fact have a die roll that comes up 1 out of 100, they begin to convert to early seral because of the stand replacing fires that we have added into the system. So you can see with this change, you get this. This might be a way of saying, if our current conditions are the product of a certain set of fire regimes, however they've come about, that reflected on average 1%, and we suddenly have a change, or we have a gradual change over time, we might be looking at a landscape that is going to be just in and of itself, based on the rules that we developed, much more likely to have a lot less in this late seral category. So this is probably like my second to last slide. basically just taking a look at the late seral, kind of rephrasing what I just said. Here for late seral only in our modeled world is how this scenario A with a 1% chance per year of a fire that could play out, and our scenario B that could come out. So that's in a nutshell the state and transition modeling approach, which can be used to find ranges of variabilities. It can be used to validate our assumptions about the disturbances in the processes that are playing out. It can also be used to validate our assumptions, particularly if we're using historic reference conditions, to validate our assumptions about those historic reference conditions by starting with what we think was in the past and what disturbances may have played out, and then essentially running those forward up to the present and seeing, do our present conditions actually fall into what we would have expected. So these state and transition models have a lot of use. I view them as very much a complementary way of working with what has been being used for the last couple decades, in the Blue Mountains at least, in terms of how we go about doing departure analysis. I think we're going to see more of this over time. And with that, my closing thought is, we have spent a lot of time with natural range of variability and historic range of variability. I think this is beginning to modify in some ways. We've looked to the past, thinking that it's probably more similar, the say fire regimes, at least in this part of the world, that those are more, perhaps have been more appropriate to what we would like to see or what we think is more stable. That's kind of been our mode of operating. I think as the awareness of a changing climate is coming on, and what that probably means for things like changing fire patterns or perhaps drought, or what that might mean with insects or where people are going to be living, that we're moving much more into this future range of variability, which is a whole lot less certain. So I want to throw in as my closing thought that we begin to think about simply reference ranges of variability. And that when we talk about our reference conditions, we define those, and to the best of our ability, we justify those coming out of the science. Perhaps it's modeling efforts supported by science, maybe it's historic reconstructions, maybe it's modeling efforts spinning forward in time, maybe it's expert opinion, a lot of different ways of doing it, but that basically we start to realize that all of these things, historic range of variability, natural range of variability, current range of variability, future range of variability, that they are all sort of specific cases of what we probably ought to start thinking about as the reference range of variability. So with that, I'm going to stop. I'm going to get out of full screen mode and send it back to Sally for questions.
Thanks so much, Nathan. Our first question is the need for spatial information to ensure treatments increase ecological resilience. That seems like a major limitation of this approach. Do you have comments on that?
Yeah, I do. So I showed the so-called aspatial. This SynchroSim STSim platform was an improvement over its predecessor, VDDT, in that it can be run in spatial mode. So you can start with a quote-unquote map, if you will, your input data not just as percentage of the landscape, but also where those things actually are, or where you think they were, say, based on a historic reconstruction. When you do that, and so this is getting exactly at the speaker's question, you also then need to define, for those things that you believe are important or relevant to answering your questions, you need to define those sort of spatial transitions. So for instance, if you have a vegetation patch that is next to one that has a high probability of having a fire start in it, and you are pretty certain, I mean, it makes total sense, right? Something that is next to something that is more likely to burn is probably more likely to burn itself. You need to also develop and I document a bunch of spatial rule sets. And the SynchroSim SDSIM software platform has the ability to do it. It's then up to the users to how far they take that. Does that answer the question?
Yes.
Okay.
All right, our next question is from Connor. How scale is chosen seems like an area that is often glossed over, but landscape versus forest versus watershed. Picking different scales could have large effect on departure analysis. How is this chosen, and are there best practices?
I don't know about best practices. I agree it is absolutely critical. I mean, scale, that is one of that has been and continues to be in life, but in my discipline in ecology, that's a key thing. I guess if I were going to give sort of just a off the cuff answer, it was that the scale you pick really needs to capture the variability that you believe is representative of the ecosystems that you're looking at. So, I use, just to exaggerate differences in this little simple model run, I used a tiny little landscape of 100 acres. It might be that, we know that that's going to be way, way, way too small for practical stuff. But, it might be that if we were looking at, say, anomalous bark beetle outbreaks, right? That, even a single forest level might not be appropriate. Maybe we need to be looking at the Blue Mountains region, or maybe we need to be working, the Rocky Mountains wide, if you're really trying to get a sense of kind of what falls within that range of variability that we believe goes with our reference conditions. Does that answer the question?
Yes.
Okay.
Our next question is, how does HRV fit in with quantitative risk assessment and other models considerations for determining appropriate treatment?
Yeah, I think that's kind of what I outlined here. Is that, again, when in general terms, there may be specific projects or things where this is done differently, but in general, we're going with some sets of reference conditions or approaches. And again, for the Blue Mountains, or at least that letter that I showed for the Wallowa-Whitman dating from 2011, the endorsed approach was what Dave Powell had put together. He, for those of you that don't know him, was the forest silviculturist until a couple of years ago on the Umatilla. And I will say that when I first came across his work, I really couldn't tell whether I was reading things put together by an ecologist, which I'd kind of consider the basic side to ecology, or a silviculturist, which I would consider more on the applied side of forest ecology, because he moves back and forth, did a fantastic job of stitching together, for instance, different classifications. But his sort of what he put together in terms of briefing papers and syntheses became the approach that was adopted for the Blue Mountain forests, with variations from forest to forest. Does that help?
Yes.
Okay.
The next question is from Adam. As you said, changing climate conditions suggest we need to move away from historical references as a primary reference in some way. Would it make sense to use areas such as wilderness, IRA, or other places with less active management as places to inform reference conditions, especially when they have experienced natural disturbance?
Yeah, absolutely. No question about it. That, in its purest form, if you were to go back to, at least for sort of contemporary, if you were looking at that, where we're not as recently disturbed by humans, although I do want to throw in the qualifying caveat, is that if we have, in this part of the world where perhaps fire was more common, if through some of our activities we've actually reduced the amount of, say, fire moving into wilderness areas, we may have altered the trajectories there. So no action does, active management does not imply normal. Or no actions, not doing something, might in fact be deflecting at a landscape scale certain patches from being on a trajectory that they otherwise might have. But I would say absolutely bring those in. Again, it depends on your question and what you're looking for. One thing I will say, it may come up as a question, but when we're looking at, I think we really have sought reference in the past. Part of the reason that I was really adamant about highlighting that somewhat, I would say, artificial view of not disturbed by humans, I think there's been a big change in the ecological sciences over the last century or so, moving from that disturbance kind of was this anomalous thing to saying that disturbance is absolutely key to maintaining certain ecosystems in certain structures. So I would view, the wilderness areas, IRAs, as one part of the picture, but recognize that just because, for instance, they might have not had fire because it's been excluded from going in, that they might be as departed in some cases as other portions of the landscape. Does that help?
We'll see. Yes.
Okay.
So our next question is the desired future structural stage distribution always based on the natural range of variation, or does it get adjusted to factor in climate change?
So that's a great question, and this is really the big unknown. We're moving into that, and I'm saying we. I'm not sitting on any ID teams. I don't know exactly how any one particular project, but definitely, I mean, as a society, we absolutely need to get a handle on this. I think, and this is going to be a sort of a speculation on my part. So don't take me as quoting. Don't quote me speaking on behalf of the agency. But I think in some ways, part of the reason that we went back to historic conditions, aside from the fact that, yeah, we're pretty certain that with fire suppression, there really was a change there. No question about it. But I do think there was, in a sense too, that in this part of the world, for instance, fire, that the systems that we've gotten in place through fire exclusion, that if we go back to sort of those 1850s, 1870s, when we have written records and where we probably didn't change the fire at that point, the change in fire patterns was maybe beginning, but still was probably a little more reflective of a more frequent fire landscape, or where we weren't trying to, snuff out every fire. That those historic conditions were probably a better guide for where we think we might have wanted to be at present. As climate change is coming on, though, let me back up. I think that in some ways, that's kind of given us some comfort, psychological comfort, because aside from thinking that those ranges of variability in the past were probably going to be quote unquote better for what we were thinking we might want to have, or maybe as we began to lose some things, we can at least look back, right, and say that existed once, or that existed in the past. We know it existed. The future thing, we may be moving into some situations. We are almost certainly going to be moving into times when what could actually be on the landscape, given, say, changing disturbance patterns, might be really novel. We can use the past to help guide us for down the road, but where we're moving into somewhat uncharted territory. That doesn't mean we're helpless. As a starting point, if you're charged with figuring out how to do this, one starting point might be to figure out, okay, let's take look at a whole lot of climate change models, and there are a bunch of them out there. Maybe take one that performs in the mid-range, and one that's at the high range, and one at the low range, and begin to, make our best predictions on where we think, for instance, a dry ponderosa pine site that might be at this location, where do we think it's going to be if the climate changes in this way, say 50 years down the road? And so one approach, not endorsed, but one approach might be to simply try to remap those vegetation types. where I think it's going to get really, really interesting is when different components of different forest ecosystems, say two different species that currently in some portions of the landscape co-occur, what happens if, say, grand fir moves in one way and larch moves in another, and they don't necessarily move in sync in the places where previously we found them together? That's a whole nother level, but you know, we're gonna have to tackle it. And I think that we are, like most of what we do, at some point we're gonna have to be making the best and most, the best really educated predictions or maybe even guesses that we can. In my opinion, simply throwing up our hands and saying we just don't know is not going to be a viable answer. And quite frankly, most of us don't live our lives that way, and science doesn't operate that way. I mean, with science is constantly being revised. I mean, take COVID-19, right? It's going on. People that aren't really thinking too much, in a science-based framework may point to the scientific community and say, yeah, they can't make up their minds, they're constantly changing it. Well, evidence is being continually reevaluated. And not everybody's going to agree based on the interpretations of the evidence. But as time goes on, we're beginning to get rid of certain things as possible treatments or things that we could be doing. And we're beginning to endorse, and in some cases more and more strongly, certain measures like masks and social distancing. Those are some sort of things that we can do that do appear to be working. So I'm not going to go off on COVID-19. I just wanted to get at this question about what happens when we're dealing with new and future climates. Yeah, there's going to be a lot of uncertainty, and we're going to have to go with, at some point, it may end up being, our best guesses, predictions based on the best available science that we've got. And that may differ for certain people. But in that case, you know what? Ideally, we're able to compare and come up with much more of a consensus on what constitutes best available science. So hopefully that answered it.
Awesome. Our next question is, could you contrast this approach with Hesburgh's landscape evaluation approach? What are the strengths and weaknesses of each?
Yes, so I would say I'm not, I'm generally familiar with Paul's landscape evaluation approach. I mean, essentially, and he's using, at least in no small part, historic air photos, okay? So early 1900s. There are probably going to be places in the landscape where that already is different. He may, I don't know, he may have compensated for that, or may have spun things back in time. Fundamentally, these are kind of, I would say complementary approaches. You could take Hesburgh's approach of, let's just say, this is what we think the landscape looked like in the early 1900s, based on aerial photos, and you could use that to validate a state and transition model. I mean, all of these, I would view these as all these different approaches. They're different kind of tools can be brought to bear on the same sets of questions, which really are, how departed is our present landscape from whatever our reference conditions are? Does that help?
Yeah. So a follow-up question to the previous one about wilderness areas is, the fact that protected area may have a deflected trajectory given fire suppression, can we look at these areas as references for what we should expect as a natural response to fire exclusion? And would such responses be considered, quote unquote, more natural than in actively managed areas?
Yeah, I'm going to sidestep the natural, because at some point, again, if something is departed, is it natural? But I do think that a place where wilderness areas, those can be places, in most cases are places, where we're more willing to let, and in fact legally have to, in many instances, let things burn. So if we want to get a sense of how maybe a particular forest type in a particular location in the landscape is likely to be impacted by a particular disturbance or have its developmental trajectory nudged or deflected based on a particular disturbance. And yeah, wilderness areas in some ways offer pretty unique opportunities because, for instance, if you could find a comparable area that, let's say, that let's just say had been heavily thinned, right? Wide spacings of trees, but otherwise with same vegetation types, elevations, aspects, slopes, the whole deal, just differed in the treatment, that would be sort of an impromptu side-by-side comparison of what happens. I mean, you might find out that the wilderness area entirely goes up in smoke, right? But, you know, flip side might be that there's may not be, if any, say, replanting in there, and the wilderness areas might be a better place to study natural regeneration following a really big stand replacing fire, or to get at the patterns, because, you know, we say stand replacing, right? But on a landscape scale, we know there are areas that have more and less in terms of overstory mortality. So again, I think wilderness areas, you know, I wouldn't view them as a control. I would view them in some ways perhaps as another kind of treatment, quote unquote, where nothing was done except maybe fire was excluded with a higher probability. Does that help?
That does, thank you. All right, here's a more technical question. FBS batch mode is used to grow up common stand exams over the last 15 to 20 years to get current conditions. Does this account for disturbances, for example, fire perimeters?
Yeah, sure. I love technical questions. So really what should happen, okay, or what should happen, does happen, going into a project like that one that I've shown that is in the process of ramping up, the Morgan Nesbitt project, is that it doesn't have to be, but it's likely to be the project silviculturist who will, before doing any kind of projection of stand exams across the project area or area of interest, I'll just say area of interest because it could be anything, but in this case, say that 90,000 acre, the very first thing that person, whoever's going to be running the data analyzer, needs to do is go through the older exams and spend a chunk of time doing two things. Number one is look at those previous exams and say, do I believe that they have not been disturbed? So there haven't been active management activities in there. There haven't been fires in there. There haven't been insects. Am I pretty certain that nothing has happened to a particular stand that had a stand exam in it that is going to deflect it such that if I take that stand exam and I grow it up, that I'm reasonably convinced that just normal growth processes without disturbances that would send it off on a different trajectory, that it's going to be able to be, quote unquote, grown in that modeled world up to the present, right? So that's number one thing that and I'll just say silviculturist, because that's typically, at least in my experience, is the person who does this. That's the first thing. The second thing, and it kind of goes hand in hand with that, let's say you had a particular stand, it had an exam in it, and half of it burned up, or half of it had been blown down, or half of it had been cut, or whatever it was. The other thing that I'll say silviculturist really needs to do is make use of another one of those GIS add-ons, the spatial, Fsveg spatial, and change, maybe split the stands in half, get rid of the stand exam plots that say are no longer good, or if you just say that it's no good, then you do what we call archiving the exam, and it's like you put it in the back room. It isn't going to be something that's going to be drawn in. So before you do that imputation or projection of exams at present, like before you grow them up to the present, you need to go through and edit them and or archive them to get them out of the picture if they're going to compromise, if they've been quote unquote compromised, really are no longer representative, and you don't feel that they can be grown up without disturbance to the present. Does that answer the question?
Let's see. Yep, it does.
Yep. All right.
Awesome, thank you. So, let me see. From Tegan, why have you decided to use seral states for reference in RV? In Colorado, the trend seems to be to use BA for reference.
Sorry, I'm not sure what is,
Let's see.
what's the, in Colorado, I heard a pair of letters.
To use BA for reference. Let's see if she can clarify.
Yeah, is that
Basal,
basal area, or I'm not sure what that is.
basal area.
It is basal area?
It is.
Yeah, you could define it anyway. I mean, in Powell, the approach that was endorsed by Powell, or I mean, the approach of Powell, that used structural stages. However, if you dive into some of the other things, I only showed one table and I picked a really small one that could fit on the screen that was fairly straightforward. There are a whole lot of things that fall into that. I mean, that break those out a lot more finely. So for instance, I mean, seral stage is something that works here, but how you define those seral stages, right, is often driven by structural metrics. And I don't know for sure on the Wallowa-Whitman because I just got over here, but I spent about 3 years on the Malheur as kind of one of their inventory people. It was the so-called forest analyst. And I dealt a lot with stand exams. Over there are some keyword files. I don't know if you're familiar with that, but they're like little programs that can be added into the forest vegetation simulator. And on the Malheur, they had eight structural stages for forest types, and then they would be broken out by like cool, moist, and warm, dry. I'm making the terms up, but essentially 8 different structural stages. And those keyword files would essentially look at, would pull out of the stand exam, like tree lists, and say this stand falls in this particular structural stage. So it kind of had a sense of time behind it, but it's not, hardwired in per se into a seral stage. Again, the thing about these models, this is kind of like going back to my second to last stage or second to last slide, is that you really need to pick you need to be very clear on how you're choosing to define your reference conditions. And when you build your models, you really need to build your models to reflect, essentially, to be able to provide the types of answers, not the answer, right? Not the numbers, but just you want to be able to build your models so that you're able to answer the pressing management questions. So for instance, if you were within the range of spotted owls, right? And you knew that being able to define spotted owl habitat is a really important thing, then it would be really smart of you to design your state and transition model if you were using that approach, so that you could characterize spotted owl habitat using some combination or maybe characteristics that go with your different structural stages. Does that help?
I hope so.
Okay. Yeah, again, there's really, the models you build them, you should be building them to reflect a particular purpose and desire. I kind of like to think about it as, 2 years down the road, and when you're standing up in front of an audience, right, what are you going to be showing them to answer the questions that you're pretty sure are going to be coming? And use that, kind of reverse engineer your things to go back to develop your models so that you know that you're going to be able to answer those questions down the road that you believe are going to be important. And I'm sure that the audience will let you know in project comments or whatever, if you've blown it. Like, did you consider this? And you, oh gosh, no, I did not consider that. Probably we should have.
Okay, great. Thank you. So tying into the spotted owl discussion, management based on range of variability can decrease habitat for sensitive or focal species, even as it brings stands closer to HRV, NRV. How much concern is there about this risk?
I would say that in any landscape, right, this is really important. Any landscape, there are going to be organisms that are not going to do well there, and there are going to be organisms that do better there, right? Particular landscapes are going to favor certain organisms, and particular landscapes are not going to be as good. If you were to rearrange things, you might be able to improve conditions for certain organisms. Conversely, other organisms might actually suffer. So I'm clearly coming from a philosophical background where active management in certain circumstances can be beneficial to certain organisms. I'll leave it at that. It's not to say that management is categorically bad or categorically good for certain organisms. It's really the resulting landscape patterns, both at that sort of vegetation patch, that's one level of sort of diversity, up to landscapes or maybe even regional or continental scales. Depends on what you're looking at. Does that answer your question? I hope it sounds like I'm not trying to duck it.
It sounds good.
Okay.
So I have a kind of a two-part question. Earlier in the presentation, you mentioned you encouraged collaboratives to do this back of the envelope approach. For collaboratives interested in doing that, what advice do you have for them to get started or to engage on this? And do you have you worked with a collaborative on this before, and how was it received? And can you speak to that experience?
Yeah, so I haven't formally worked with a collaborative on this, but I remember where this really occurred to me was I was on a field trip with the Northern Blues Forest Collaborative, which is now one, but collaborative groups on the Umatilla and Wallowa-Whitman a year or so ago, I can't remember exactly when it happened, kind of merged. There was a lot of overlap. Some of the vegetation types, there's actually a fair amount of overlap in vegetation types. A lot of the members of the collaboratives were the same. And so there was a decision, let's just make one and work across both forests. But anyway, I think we were on a field tour up in the La Grande City watershed, really neat place. And I remember this one area we were overlooking, it was kind of hilly terrain, kind of, lava flows going through it. So we could kind of be perched up looking down on something. And it really was diverse and variable. We knew that some logging had happened in portions of it, and it was right near where the dam had been constructed for that reservoir. We knew that there'd been a lot of active management in there, but this incredible mix of species. And basically, without actually pulling out an envelope or taking notes, what the group was engaging in was, how did this thing come to be this way? And that conversation, that's when I realized, really what we're doing here is building a series of state and transition models, and maybe optimistically, right, we would have those different viewpoints, different people's expertise. Some people are going to see different things. Some people are going to have different thoughts. Hopefully, right, if you had those, you'd get everybody to coalesce around a common kind of back of the envelope model. You'd be keeping a tally of these are the disturbances that we think influence it. You'd ideally come to an agreement on, okay, what do we think was here in 1870, right, to start this out. You probably could, with direct measurement, this would be another great exercise for the collaborative, go ahead and put in your own inventory plots so you could actually characterize right there. I think that'd be a fantastic thing for people to do. But I think that you could build a model, and for those areas, I mean, the great thing about this is once you moved it from sort of that back of the envelope world, and where maybe points of disagreement, like how common were these different intensities of fire, let's say that's a big disagreement. Like right now, I can say that in this part of the world, there's a bit of disagreement about the amount of, say, lower intensity, moderate intensity fire in some of our cool mixed forest types, right? This would be a perfect opportunity to build a state and transition model, come to an agreement on what we currently have, come to an agreement on maybe what you had or what your reference conditions ought to be, and then game out, just as I kind of did a couple slides back, if your sticking point is we think we've got, not very much moderate low intensity fire in these forest types, game that out as one scenario and take another one with this is what other people think that fire probability. If the collaborative, and this is a general rule of thumb for dealing with any kind of group, if people are involved, and this is one of the strengths of the collaboratives, if people are involved in building a model or coming up with a solution or collecting monitoring data, right? They're much more willing to accept the outcomes than if somebody simply holds up a model. I think it's really unfortunate when somebody opts not to participate in multi-party monitoring. That's a really unfortunate thing. In the collaborative arena, again, one of the great strengths is that you can have people from all different backgrounds and you bring them together, they participate in it. You know, even if there's surprises, right? People are much more willing to listen to surprises if they have played an active role in doing this. And I'll say, and this, I do have one personal example, is I ran a collaborative group. It's not my training at all, but I ran a collaborative group, the Clackamas Stewardship Partners, for about 5 years on the Mount Hood. And one of the most successful things that came out of that was multi-party road closure monitoring. Essentially, how successful are different our closure types across the Clackamas River Ranger District. It's a big area. We had a bunch of different entities ranging from environmental groups to timber, to hunting groups, to the Soil and Water Conservation District, the Watershed Council. And you know, I set up this random stratified design. I had QA/QC in where people would go out and remeasure things that another group had measured. We had a really simple, like 5 scoring system, not breached, to maybe foot traffic, to, you know, somebody went through here with a Jeep kind of thing. And at the end of the day, you know, everybody accepted the results because all the parties had been involved in collecting the data. We had discussed how to set this thing up, and it was really cool. I mean, I'm Forest Service now. At the time I was not, but it was really cool because in responding to public comments on road closures, I can't even remember what the project was, but there were questions about that the Mount Hood used, or the Ranger District, used that multi-party monitoring study on road closure effectiveness to answer questions about the effectiveness of road closures that were coming as part of the public comment period. So again, I think there's great value. I would keep it super simple, but make whatever you end up doing as, you know, as defensible as you can. So does that help?
That does help. Thank you. It doesn't look like there are any other questions in the chat at the moment.
All right.
This has been awesome. I'm going to turn your screen off in a second and turn mine on.
Okay.
So we did have a question earlier if the PowerPoint was going to be available later.
Yeah.
You willing to share?
Yeah, absolutely. So yeah, I'll pass it over to you. I will have to set up I think it's going to be too big for me to email, but okay. On this one, everything's bundled in one. It's maybe, I don't know, 20 slides or something like that. Mm-hmm. So I can try to email it to you first, and I'm sure you guys have, you know, file transfer systems that we can make use of. But yeah, I'll, maybe either later today or right after we're done here, Sally, we can try on getting this, you know, to you. But you know, I know that it was recorded. I had no issue with it. I let Sally know that I knew that it was being recorded and that I was fine with it. So yeah, it'll be out there.
Awesome, thank you. If there are any other questions, please feel free to let me know and I'll share them with Nathan. Thank you, Nathan, so much for helping us out with this workshop and for leading this discussion. This has been awesome. I really enjoyed your presentation and I hope others did too.
Great, thank you.
Workshop is part of a series. The 2020 Pacific Northwest Forest Collaborative Workshop has gone virtual this year. There'll be webinars, approximately 2 per month from now through October. So stay on the lookout for those. August have been posted and I can follow up with anyone who's interested in them after this. We do have 6 sponsors for this workshop: Hampton Lumber, Oregon Department of Forestry, the Forest Service, Beneficial State Bank, and Timberline. Those are 5, not 6. Thank you to all of our sponsors for making this possible, and thank you for everyone for participating.